what you need to do to make the inverse a function is restrict the domain of this original thing here. If we only look at the tangent function between here and here, then its inverse is a function. Okay, so if you graph it, it's only going to be this part reflected over the line y equals x. So let's go back to this and we'll see here. Move this over. So we're going to delete this. And we're going to put in here. Now, inverse trig functions, you can call it two different things. You can call it sine with the little -1, x. Or if you were in university, they would probably more likely call it arctan or arcsine, meaning inverse. Okay, arctan means inverse tangent. Arcsine means inverse sine. It's actually a better language or better symbol for it than sine with the little -1 because you get confused with reciprocals and everything. But that's the inverse tangent. It goes horizontally. I'm thinking I can draw just on this software. I'm thinking I can restrict the domain of this thing if I put tan x, but then I say negative. Oh man, pi over. Where's pi here? Did you see a pi in there somewhere? I do. Negative pi divided by 2. I'm sorry if this doesn't work. For some stupid reason, you have to go off of the letter and then back. Pi divided by 2. Wonderful watching someone else use a computer. This might work. Okay, so that's the way I did that was just graphing the tangent function, but saying I only want to show it between negative pi and pi. We should maybe make this a different color so you can see the difference here. What color do you want it? How about red? It's amazing how everybody cares all of a sudden. Well, at least you can see the difference there. This is the tangent function restricted between negative pi over 2 and pi over 2. Its inverse is you switch the domain and the range, right? So it goes horizontally here. The tangent function has vertical asymptotes. The inverse tangent function has horizontal asymptotes. The other ones are going to be the same thing because all the trig functions are periodic. Since they're periodic, their inverses are not functions. So to talk about inverse trig functions, you have to only look at a restricted part of the original function. You sort of already know this, but you don't realize it on your calculator because now what mode am I in here? Radian, that's good. If I put in tangent of whatever here, 0.7 radians, or if I put in tangent of something else here, tangent of 8.7 radians or whatever, you get a value, right? If you do the inverse, it's always going to give you answers within the first, between negative pi over 2 and pi over 2. Perhaps we should think in terms of degrees for this because it would be easier to think about. So our brains don't hurt here. Okay, let's switch to sine here for a second. Sine of 30 degrees, what's that? Sine of 30 degrees, you know this, don't you? Triangles. 1 over 2, thank you, 0.5, right? Give me another angle that has a sine ratio of 0.5. 150. Give me another one. 210, you think? It's going to be negative. Yeah, we got to go past one full rotation here. Now, so what that's saying is I put in a unique x value here. There's only one y value. There's only one sine ratio for each angle I put in here. But if I turn that around and make it the inverse, right? Here I'm saying here's an angle, what ratio goes with that? Whatever angle you tell me, there's only one ratio that comes up. But if I turn it around, the fact that this same ratio, there's a bunch of angles that have that same ratio, if I talk about the inverse, it's not a function because you can't have one value give you 3 different angles, right? All the solving trig equations you've done, you're given a single ratio and you can find lots of angles that have that ratio. The inverse is not a function. So if you restricted it and said we're only going to look between 0 and 180, or negative 90 and 90. For the sine inverse function, let's just stick with degrees for a second here to keep our thinking straight. If I do sine inverse of any of this 0.5 here, it can't give me all three of those numbers. It just gives me the one closest to the y-axis. It only goes between negative 90 degrees and positive 90 degrees. If I was to put in sine inverse of negative 0.5, it's going to give me that. It doesn't give you those other ones. It's restricted. All right, so relate that to how your calculator works. I don't know how much there is to write about this over here in your notes. Inverse trig functions are going to come up later. Again, as I said, you can write them like this, or you can write them as using that other notation, arc sine of x. If you're using that GeoGebra program, that's how you put it in there, which is, again, better probably. Arc tan, arc sine, arc cosine. Okay, again, not really a whole lot to do here. Incidentally, if I said, if you have y equals tan x, to come up with the inverse of this, I would write x equals tangent of y, right? No, I don't want to confuse you. I'm going to switch them here. X equals tan of y, right? The inverse is switching x and y. This is writing x as a function of y, reversing it. If I want to change that and write it as a function, y equals tan inverse of x. This is a function. This is going to give you only that part. I think, and I'm not sure, I haven't tested this, and it's always good to try things in front of people that you've never tested because it never works the way you want. I'm thinking if I put in here x equals tan of y, I'm wondering what I'm going to get. What do you think I'm going to get here? That's what you thought? Did it actually do something? Oh, illegal argument. It doesn't like to do functions like that, but if I wrote x equals tan of y, it should be a whole bunch of curves if I'm writing it the other way, not just this one. But if I write it as it's arc tan of, I noticed they abbreviated it to a tan, so a tan obviously stands for arc tan. Okay, that's just, if inverse trig functions come up, they're not going to come up that much, but if they come up, just realize that they're functions. Any of the buttons on the calculator you can do as functions, right? Normally you first learn these things as operations and then you look at them as functions later. You obviously learned about these operations, plus, minus, times, divide, years ago. And then you look at functions involving those. Then you learn about square and square root. And after that you learn about them as functions. Then you learn about sine, cosine, and tangent. And later, grade 12, you start graphing them. This is the first you've graphed the inverses. Just realize they're restricted to make them functions. Any questions about that? Let's stop.